The next example iterator we're going to look at is an implementation of group by that assumes a sorted input. It's a common implementation of group by, but not the only one. This particular implementation of group by requires the optimizer to make sure that its input is sorted, perhaps via a pipeline like the one at the top right of the slide. All right, but we're going to assume the input is sorted, and we're going to look at what the algorithm does. So the init function for this iterator is pretty simple. It takes the grouping keys from the group by clause and a list of the aggregation functions from the select list. It recursively calls child.init, and it sets the current group to null. The next call from this group by is simply going to need to fetch enough tuples from the child such that it gets all the tuples with the same group by value, and then it's going to summarize them and send them to the output. Now, to understand how aggregation works in a group by, we have to realize that there's different aggregation functions that have different state that they need to maintain. So over on the right, there's this table in red that describes some of the aggregation functions that are commonly implemented: count, sum, average, and min. And you'll see that each one of them maintains a particular piece of state and has a function to initialize, a function to merge in a new value, and a function to finalize the output of the aggregate. So briefly to go through these, before we go into the next method of this iterator, we should understand these aggregates. So for count, the state that it keeps is the count so far, which is initialized to 0. And as we look at new tuples, we're going to increment that count. At the end of the aggregate, we're simply going to return the count so far as the total count. Sum is quite similar. It's got a state called sum, initialized to 0, but as we see values x, we're going to sum them in to the sum plus equals x, and then the final value is the sum so far. Average is a bit more interesting. It keeps two local state variables, a count and a sum, initializes them both to 0, and then uses them just like count and sum are used for merge. It increments the count, it adds to the sum, and then the final function for average takes the sum divided by the count and returns that average. Minimum has a little bit of state, just the minimum so far. It's initialized to positive infinity, okay? And then the merge function basically says if the new value x is smaller than the minimum so far, then set the minimum to x. Otherwise, keep it at minimum, and it returns the minimum at the end. So those are examples of aggregation merge functions. So now we're ready to look at the next method of the group by. It begins by initializing a null result tuple. And then there's a loop which is going to repeatedly call child.next, fetching tuples from the current group until it sees one tuple from the next group. At that point, it's going to aggregate up the tuples from the current group with the final function and return the result. Let's see how that works. So we call tup equals child.next, and we get a tuple from the child. Now, if the group of that tuple is not the same as the current group, there's two cases. In the first case, it could be that we just started the algorithm. It's our first call to next, and cur group is null. In that case, we skip these two lines. However, if cur group is not null, then we're going to be ready to form a result, because what we've done is we've seen a tuple that's different from the tuples in the current group. So the result we're going to form is got the values of the group by columns for the current group, and we're going to call final on all the aggregation functions in our select list to compute the final result of the aggregates. And that's going to be our result tuple. But we're not going to return it yet because we've already fetched the first tuple of the next group, so we need to take care of that. So we'll set cur group to be the group of that next tuple, and we'll call init on all the aggregates to initialize them to prepare for tuples in this new group. And then finally, we have to take this tuple tup, whether it was in the current group or whether it's the first tuple of the next group, and we merge it in to the state of the aggregates for all the aggregates. When we've done that do loop, if we have a result, it means we found a new group and we formed a result tuple for that group, and we can return it to the output. Okay, and if not, we just go through the do loop some more, merging in some more tuples. Once we have a result, we return it, and that's the end of next. And close is straightforward. Close simply closes the child recursively. So an interesting thing about this group by algorithm is that it keeps only one tuple in memory at a time, and it merges the values from that tuple into the aggregate functions. And then it goes and it fetches another tuple. So it never has multiple tuples for a group in memory at once. It simply maintains the aggregate function by calling merge, 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 and then eventually calling final for each of the aggregates. So it's very memory efficient. Okay, and we've seen enough operators now to imagine how a full query plan works. We could do a group by over a sort, over a select, over a heap scan. That's a pretty, reasonable SQL query, single table SQL query. And so you should think about how this would work by calling the init and next functions of all of the iterators we've seen so far. Remember, this query plan is single-threaded, so there's a thread at the top that says init on the group by, and that's how the whole thing begins till it returns. And then the thread at the top will repeatedly say next to the group by until it gets an EOF. So everything that happens below that is happening within this thread by recursive calls of init and next. And you should think about how this works by tracing through in your mind the code that we've seen so far. So when I call init on that root group by, how does the init recurse down the chain and return? And when I call next on the root group by, how does that recurse down the chain and return a tuple? So you should think about how those work and understand the interplay between these different iterators. Note how the blocking operator sort interacts with the other streaming operators. Group by is more or less streaming, and select is absolutely streaming, so think about how those relate. And note also that we don't store tuples on disk at the output of every iterator. Rather, the tuples are passed back through the call stack. The next function, when it returns a tuple. That's how tuples get passed from one iterator to the next, by the return value of next. We don't store the output of sort, for example, on disk. We simply return it one tuple at a time via next to group by. Now, of course, sort's going to use disk internally for its runs, but the arrows you see in these query plans don't actually represent any storage of data on disk. They simply represent the return of a next call. And so this iterator model is actually very lean with its use of memory. Whenever we use memory or disk in a large way, it's happening encapsulated inside an iterator. So the iterator framework itself uses very little memory.